In this part, we'll speak about a set of equations known as the kinematic equations, and those equations are for a particle under a constant acceleration. We'll learn after in this chapter how to derive these equations. The kinematic equations may be used to solve any problem involving one-dimensional motion with a constant acceleration. So please, these equations can be used only for a particle or an object moving under a constant acceleration. You may need to use two of the equations to solve one problem, and in many times there is more than one way to solve a problem. So all the methods are considered to be correct. The first equation is related to the velocity. The subscript x and f represent x for the x-axis and f for the final, and I is for the initial. So when we have a constant acceleration, a particle is under a constant acceleration, the final velocity vxf equals to the initial velocity vxi plus ax times t. Time is the time. This equation can determine an object's velocity at any time t when we know its initial velocity and its acceleration. Assumes ti equals to 0 and tf equals to t. In this equation, we assume that the initial time is 0. This equation does not give any information about displacements. The second equation represent the final position of a particle in terms of velocity and acceleration. So the final position xf equal to initial position xi plus vxi times t, t is the time, plus half ax, ax is the acceleration, times t squared. So this equation gives the final position in terms of velocity and acceleration. Does not tell us about any information related to the final velocity. So if you want to determine the final velocity, you should use another equation. And for the third equation, which is an equation not depending on time. So it gives us the final velocity in terms of acceleration and displacement. xf minus xi is the displacement. So the final velocity squared equal to the initial velocity squared plus 2ax, ax the acceleration, times displacement xf minus xi. So in this equation, we don't have any information about time. And if you have an exercise and you don't have in this exercise any information about time, you can use this equation. If we have a graphical look at a motion, so if we are representing displacement time curve, the slope of the curve is the velocity, as you know. If we are searching for the initial velocity, so the slope at xi will be the initial velocity. And if we are searching for the final velocity, the slope at xf will give us the final velocity. The curved lines indicate the velocity is changing, therefore there is an acceleration. And in all our cases, we are dealing with a constant acceleration. And if we represent velocity time curve, the slope will give us the acceleration. The straight line indicates a constant acceleration. So if you want to determine the acceleration, you will search for the slope of this velocity time curve. and this slope ax is a constant. Finally, if we have an acceleration time curve, as it is representing here, the zero slope indicates a constant acceleration. So if you have a zero slope, it means that acceleration is constant, and you can see that by this horizontal red line, meaning that the slope is zero. So having a constant acceleration will lead to a zero slope. In all of our case study, we will deal with a constant acceleration.